Some of the hardest problems in mathematics don't look hard at all. In fact, a child could understand them. Simple rules, simple patterns. And yet, even the smartest mathematicians on Earth haven't been able to solve them. Not because they're complicated, but because they're deceptively simple.
In mathematics, an unsolved problem isn't something we don't understand at all. It's something we do understand, but can't prove. We can test it, we can check millions, even billions of examples, and it always seems true. But until someone proves it works for every possible case, it remains unsolved.
Let's start with something incredibly simple. Pick any number. If it's even, divide it by 2. If it's odd, multiply it by 3 and add 1. Then repeat the process, again and again. For example, start with 6. 6 becomes 3, 3 becomes 10, 10 becomes 5, and eventually, no matter what number you start with, you always seem to end up at 1. This is called the Collatz Conjecture. It's been tested on numbers far beyond anything you can imagine, and it always works. But no one has ever been able to prove that it will always work. Now consider prime numbers, numbers divisible only by 1 and themselves. Some primes come in pairs, like 3 and 5, or 11 and 13. These are called twin primes. The question is simple. Do these pairs continue forever? Do infinitely many twin primes exist? We found them again and again, no matter how far we search. But we still can't prove that they never stop. Here's another simple idea. Take any even number greater than 2. According to Goldbach's conjecture, it can always be written as the sum of 2 prime numbers. For example, 10 equals 3 plus 7. 20 equals 3 plus 17. It works every single time we test it. But again, no one has ever proven that it works for all numbers. Not all unsolved problems are about numbers. Some describe the physical world itself. The Navier-Stokes equations try to explain how fluids move, like water, air, and smoke. The equations are known, and they work in many situations. But under certain conditions, we don't know if their solutions always behave smoothly, or if they can suddenly break into chaos. Solving this problem could transform physics, engineering, and our understanding of nature. These problems may seem abstract, but solving them could unlock entirely new areas of mathematics and lead to breakthroughs in science and technology. Sometimes the simplest questions lead to the deepest discoveries. So next time you see a simple pattern or a basic rule, don't assume it's easy. Because in mathematics, simplicity can hide infinite complexity, and some of the simplest problems may never be solved.